This walkthrough consists of 11 different scenes. Have a good look around in all the scenes to check out the activities taking place in the different locations. You're currently in the pit bottom. The pit bottom here is the logistics hub for all the materials entering and leaving the tunnel, as well as the point of access for personnel into the tunnel. Several operations are carried out in this area, including loading segments onto the locomotive segment bogies and a variety of other lifting operations. Here you can see the locomotive being shunted into position to complete the segment loading operation. When you look up, you can see the yellow gantry crane moving overhead and into position to pick up the final bundles of segments to lower and load onto the third segment bogie. Note the personnel around the pit bottom control cabin. The two operatives seen here with orange helmets manage loco movements and lifting operations in the shaft and pit bottom and ensure other personnel are kept away from hazardous activities. Suspended loads and plant movements are the key hazards in this area that need to be managed and controlled. Be sure to get permission from the pit bottom personnel when accessing any controlled access areas in the pit bottom. Additional safety controls at the pit bottom include a shaft alarm to warn when lifting operations are about to take place and to ensure that nobody is in the area. There is a designated walkway that pedestrians must follow to gain access to the tunnel and stay safe whilst doing so. You will see the locomotive is travelling into the back shunt, a short section of tunnel that has been created in the shaft on the opposite side to the main tunnel. This allows loading and unloading of the various plant and equipment required for the tunnelling operations to take place onto the rolling stock being pulled by the tunnel locomotive. Radio communication is used to manage both lifting operations and locomotive movements using two separate radio channels. In the tunnel. The tunnel is the conduit by which materials move, here by tunnel locomotives and rolling stock, from the pit bottom to the TBM. Note the tunnel loco as it approaches and passes you. Remember, when the light on the loco is white, the loco is moving towards you. When the light is red, the loco and train is moving away from you. The tunnel locos have a horn signalling system to communicate movements to personnel in the tunnel. 2 toots of the horn means that the loco is heading from the pit bottom to the TBM, while 3 toots, as can be heard here, signals movement in the opposite direction from the TBM towards the pit bottom. As the loco passes, you will see flatbed bogies and segment cars as part of the rolling stock being pulled behind the loco. The flatbed bogies can carry a variety of different materials secured in place by ratchet straps or other suitable means. The segment bogies are used for the delivery of segments to the face for ring building purposes. Look downwards and you can see the loco track. Access to the track is restricted to locos and the track maintenance team only. A permit is required for personnel to work on the track. The designated walkway must be used when on foot in the tunnel. There are hop-ups at regular intervals along the walkway that allow personnel to access the tunnel invert from the walkway and vice versa. On the opposite side of the tunnel, you can see the conveyor system. Here, this is a continuous conveyor belt sitting on the red rollers mounted in the grey conveyor support brackets. The conveyor runs along the tunnel from the TBM to the pit bottom, carrying the spoil excavated by the TBM. Regular maintenance of the conveyor is essential. A pre-start alarm sounds 3 to 5 seconds prior to the conveyor starting. Emergency stop pull cords are provided to minimize the risk to persons working in the vicinity of the conveyor. Above the conveyor, you will see yellow ducting. This yellow ducting forms part of the tunnel ventilation system. Ventilation is supplied along the tunnel via the yellow ducting attached to the roof of the tunnel. The ventilation system is fitted with an alarm to warn personnel if there is a failure of the system. The system continuously supplies fresh air along the tunnel during the tunnel construction process. This is the access location onto the TBM. From this point on, the TBM backup systems can be seen. The TBM backup is towed along the tunnel as the TBM moves forward. Plant and equipment on the TBM backup are needed for the excavation and build cycles involved in the creation of the tunnel. Look around you. A variety of service paraphernalia is stored in this area, and good housekeeping standards must be maintained to allow safe access to and from the TBM. The blue-painted timber with coat hooks seen here is a storage area for MSA Savox self-rescue equipment. Personnel can store this equipment on the hooks when they are working in this immediate area. Various locations along the TBM are identified in the same way as a mechanism for operatives to store their self-rescue equipment in their immediate vicinity. See the large metal pipes, large black hoses, yellow and red cables running along the service support brackets connected to the wall of the tunnel. These pipes and cables carry the services required for the tunneling operation, such as power, air and water. As the TBM advances, service pipes and cables are extended in this location. Follow safe systems of work to ensure that services are isolated and depressurized when needed to prevent any uncontrolled release of high pressure or stored energy from water, electrical, air, hydraulic and other associated systems. Above the service cables you can see the yellow 300 number stenciled onto the wall of the tunnel. This is a tunnel chainage marker. The ring number 300 marker here indicates the position in the tunnel. This is especially useful in relation to recording maintenance and inspection activities. It is also a useful aid to communicate the location when coordinating a response in an emergency. The green pipework you can see above you is part of the fire suppression system which runs along the TBM. You are now at a location further along the TBM backup, getting closer to the TBM. Locos navigate through the TBM backup gantries to deliver materials and components into the TBM. Space is extremely tight, so loco movements are strictly controlled. Atmospheric monitoring equipment and other ancillary devices can also be seen in this area. Look along the TBM backup to see the coloured rope lights that are flickering red here. These lights run the length of the TBM backup. The lights signal and indicate loco movements in the TBM. When the light is switched to green, this signals the loco to move in by, towards the TBM. When switched to blue, this signals the loco to move out by, away from the TBM. When red, all loco movements will stop. When the Manchester gate is open, this allows the loco to proceed into the TBM when the green rope light is illuminated. A Manchester gate is the term used for the barrier that is installed across the track at the rear of the TBM backup. Where a Manchester gate is installed, it must be kept closed until the fully coupled train is ready to move into the TBM. Attached to the walkway handrail close by, you can see a coiled yellow cable. A number of service cables provide the electric, control and communication systems that power much of the plant and equipment along the length of the TBM. Qualified electrical personnel ensure that cables and other electrical components are safely isolated before extending cables or performing routine maintenance. Cables should always be kept tidy and out of the way of personnel. This will reduce the risk of trips and falls. Electrical voltages range from 11,000 volts, main TBM supply, down to 110 volts for operating small tools and ancillary equipment. Immediately above the coiled cable, there is a red, cone-shaped device. This is an audio-visual alarm which will activate in an emergency condition to indicate an atmospheric alarm or fire on the TBM. To the left of the coiled yellow cable, you will see a box-shaped structure with equipment inside. This is one of the atmospheric monitoring points. This equipment is constantly monitoring the atmospheric conditions in the tunnel. In the event of a buildup of harmful gases, you may need to or be instructed to make your way to a place of safety. This may mean immediately evacuating the tunnel, if it is safe to do so, or making your way to the refuge chamber if your route to the surface is blocked. Note here that no materials or tools are stored along the TBM backup walkway. The walkway needs to be kept clear at all times to allow safe access and egress along the walkway. You are now stood looking into the entrance door of one half of the refuge chamber. This is the Tbm Refuge Chamber. Two containers sat side by side on the upper level further along the TBM backup. If you are unable to exit the tunnel during an excavation, you should make your way to the refuge chamber. The refuge chamber has a self-contained atmosphere to protect those in the refuge from any irrespirable atmosphere outside of the refuge for a minimum of 24 hours. This half of the refuge chamber can hold up to 16 people in the event of an emergency. This is identified by the green numbered display above the circular glass portal. As previously mentioned, the minimum air supply for any rescue chamber is 24 hours. However, additional supplies of oxygen can be used to extend this time. The refuge chamber should also have supplies of water and food to cover occupancy up to the maximum number of people who are on the TBM at any one time for the maximum duration specified. You are now stood at TBM control cabin door. The control cabin is also situated on the upper level of the TBM backup, further along from the refuge chamber towards the TBM. All the necessary equipment for controlling and monitoring the status and progress of the TBM can be used and viewed here by the TBM operator. Here you can see the TBM operator monitoring the various screens during the excavation cycle. The TBM operator, or TBM pilot, controls the TBM excavation, and his responsibilities include steering the TBM, controlling the rotation of the cutter head, managing the cutter head pressures, and controlling the rate of advance, the rate at which the TBM is pushed into the ground. Additional responsibilities include monitoring parameters to ensure safe, steady, and smooth advance in various ground conditions that could be encountered. Here, the TBM is being operated in Earth Pressure Balance Mode, EPB. EPB means that the excavated material is used to support the tunnel face whilst it is being plasticated using foam to make it transportable and impermeable. TBMs can be configured in different ways to suit different ground conditions. In the event of an emergency, the operator has the ability to shut down the TBM and make the tunnel safe. When you look to the right from the control cabin door, you can see a box with a green light showing, mounted on one of the pipes running along the TBM backup. This is part of the noise monitoring system. The traffic light warning system here will signal a breach of preset noise levels in this area. The green light showing indicates that the noise level in this location is currently okay. Looking slightly to the right of the noise monitor, you can see a red box. This is the fire alarm call point. This is one of many alarm activation points on the TBM in this immediate area. To the right of the fire alarm call point, you can see a first aid box hanging from a hook. Emergency equipment, including first aid kits, can be found at designated locations along the tunnel and TBM. You have now reached the grouting station location. Again, this is located on the upper level of the TBM backup, above the loco track. This is the location where the grouting process is controlled by the grouting system operator, the TBM operative that you can see at his location. During the excavation cycle, grout is used to fill the annulus behind the tunnel segments. Grouting minimizes surface settlement and helps to seal the tunnel and prevent water ingress. When you look away from the grouting system operative towards the back of the TBM, you can see an array of pumps and pipework stacked 4 high. This makes up the grouting system. In the grouting system, various liquids pass through the pipes and equipment at high pressure to create the grout being used. Before performing maintenance, grout pipes should be safely isolated. Uncontrolled release of grout at high pressure can cause serious injury. A permit system and isolation arrangements must be incorporated into the safe system of work. Here, the grouting system operator is monitoring flow rates, volumes, and pressures. Whip checks and restraints should be fitted to all small diameter hoses where they are connected. Large diameter hoses have R-clips inserted into the hose clamps to prevent accidental opening. Additional responsibilities of the grouting system operator include ensuring that the volume of grout required for each advance is available and used to ensure that the annulus is fully grouted during the excavation cycle.
Hey, we got success in the building. This is June and he's on the road to 1 billion. Let's go. Hey, said this is June 1 billion and we gotta make it happen. Ain't no limit, no ceiling. 1855 June billion. Success is what he wants. Make sure that you check the site, june1billion.com. Hey, gotta feel him. Ain't no limit, ain't no ceiling. If you ready, then let's get it. This is June 1 billion. Woo! June 1 billion. Hey.